Okay, so here's a short tutorial on how ions form. Ion is just a charged particle, and I'm going to show you how those particles become charged and why they become charged, okay? We have talked about valence electrons before. They are the electrons on the outermost part of the atom that are available for bonding, is usually how they're described, okay? So this is how they go. So this whole row has one valence electron, this whole row has two, and then we're just the main group elements here, 3 valence, 4, 5, 6, 7, and of course noble gases have 8. They are stable. They don't want to bond because we know they're all trying to get 8. It's called the octet rule, okay? So let me explain ions. Take beryllium, for example, Be. It's right here, beryllium. This is what I'm looking at. Beryllium has 4 protons and 4 electrons. You guys know how to do that. We've already done that. We take the atomic number, which is 4, and that tells us it has 4 protons and 4 electrons. Now, the problem is that beryllium has 2 valence electrons. It does not like having just 2 out there, okay? They all want to ideally have 8 or have a stable, or just have a full outer energy level. Usually that's 8, all right? Now, since beryllium has these 2 electrons on the outer level, it can, if it got rid of those 2 valence electrons, it could be stable in its innermost energy level, okay? So if it has 2 valence, which are outer electrons for bonding, it could get rid of them and drop down to 8, okay? Now, it's easier for beryllium to get rid of 2 than to try to get 6 more, okay? Because you see, beryllium would have to obtain 6 electrons to have 8. Well, it's easier for beryllium to just get rid of these 2, all right? So that's what he's going to do. When beryllium bonds, he's going to lose 2 electrons. So he starts out with 4 and 4 when he's stable, okay, and neutral. Sorry, not stable, neutral. He's going to get rid of 2, and then, of course, he would have 2 left, right? So now, this is how many protons and electrons beryllium has when it's an ion. Now, protons are positive, electrons are negative, so you can see that beryllium has 2 more positive charges than negatives. So an ion for beryllium would be written like this. Okay, that's a plus sign. Sorry, 2 plus. Okay, so let me do another one. Let's do one in this one. Okay, let's do K, potassium, right here. Potassium has 19 protons. It also has 19 electrons when it's neutral. Okay, now, again, the problem is that potassium also has 1 valence electron. He does not want 1 valence electron, okay? They ideally wants 8, okay? But it's too hard to get 7. He would rather just get rid of that 1 and then drop down an energy level. So that's what he's going to do. He's going to get rid of one of his electrons. So instead of 19, he'll have 18. All right? Now he's got 1 extra positive particle than he does negative. So his charge would be a plus 1. That's how you would write the ion for potassium. We don't write 1s in chemistry, so that positive is sufficient. That's the ion for beryllium. Okay, let's do another one. We're going to do one from each row so that you kind of hopefully understand this. Aluminum. Let's do aluminum next. Aluminum has 13 protons, would also have 13 electrons when they're neutral. But he also has 3 valence electrons, and he's going to get rid of those, just like the other 2 did, so that he can be stable. And since he now has 3 extra protons and electrons, it's going to make a 3 plus ion. That's how you would write aluminum, an ion for aluminum. All right. We don't usually do these. Carbon's very stable. It's special because it has 4 valence electrons, and we'll talk more about carbon in the next chapter. All right, let's start over here. Let's do chlorine. All right, so this is going to be negative, so these are a little different. Chlorine has 17 protons and 17 electrons when it's neutral. Look, chlorine has 7 valence electrons. He could easily just get 1 from somebody and boom, he's got 8, right? He's happy. So that's what he's going to do. he's going to gain one from somebody else so that he can get his 8 valence electrons and go up. Once he does that, he has one extra negative particle. Remember, these are negative, these are positive, okay? So chlorine would have a -1 charge because he's got one extra electron. All right, I'm going to do one more. Hopefully you see where this is going. Oxygen here, he has 8 protons and also 8 electrons when he's neutral. But since he has 6 valence electrons, he needs 2 more to have 8. He's going to get 2 more. Then he'll have 10. He'll have a -2 charge because he's got 2 extra negatives. All right. So what you can go ahead and write on your periodic table is that elements in this row always make a +1 ion. Okay. And let me switch how I wrote that because we're going to write it on the other side. And we don't usually write ones, but you can go ahead and write it for this just so you're clear on what you have written here. These make +1 ions. These make +2 ions. All of them do, every single one of them. And these make +3 ions. We're not going to put anything here. If you want to put Na, that's fine. No charges there. These guys make -1 ions. These guys make -2 ions. And these guys make -3 ions, all of them. Okay, so there is an explanation of ions and why they make the charges that they do.